Hi everyone, this is Mr. Youngren again, and we are going to actually continue to factor, but now we're going to take it again one step further and factor some bigger polynomials, so something that is bigger than a quadratic, and we're going to call those cubics. But before we get into that, as always, you're going to have an opener where you're going to do exactly what we learned in our last lesson and factor the three quadratic terms. Now, as always, make sure you're checking for a GCF before you begin. Once you've done that, remember that most of these are probably going to have an a value other than 1. So when you're trying to find the two numbers that meet your two conditions, remember that those two conditions are that they need to add to b and multiply to a times c. All right, so go ahead and hit pause, work through these. I'll have the solutions pulled up here in just a second. Right here is the work for the warm-up problems. Nothing too different than what we seen from our last lesson. Numbers are kind of large in this first one, so finding those can be a little tricky, but as long as you have a calculator nearby, you should be able to play around with those numbers, just like I explained in that last video. And yeah, that's really it. So the only one that has the GCF is this third one. You don't need to take out the greatest common factor of 3, but what that does for us is when I do recognize that there's a GCF, is it now allows me to work with smaller numbers, which makes finding those numbers that need to add to b and multiply to a times c so much easier. So always make sure we're in that habit of looking for GCF because, like I said, it can save us a lot of time and a lot of effort. So make sure you have all this down. And then we're going to actually jump into our lesson where it's going to be fairly short. And really, we're going to continue using these boxes and not much is going to change. So now, instead of us factoring a quadratic, where a quadratic means our largest exponent is a 2, we have an x squared. But now we have all these functions that are going to have x cubes or something to the power of 3. These are called cubics. And we can factor cubics in a very similar way of how we factor quadratics. In fact, I think it's a little bit easier because we don't need to find two numbers that add to something or multiply to something. We just need to take each term and place them in the boxes and then work on that puzzle trying to find the outsides. So like it says up here, we can factor cubic polynomials that have 4 terms the same way we factor quadratics, and we still want to look for a GCF. Now, there's no GCF in number 1 because that a value there is 1, so we can't take out anything further. So what we're going to do is we're going to take all 4 terms and put 1 in each box. Now, the one thing that we need to do to allow this to work out real nicely is put the x cubed in the top left and just that number in the bottom right. The other two don't really matter where they go. I'm going to put the x squared always up top with the x cubed, and then 8x in the bottom left. These two could have been interchanged, and you still should get the exact same thing. But just to be consistent, I'm going to always put x cubed top left, x squared top right, x in the bottom left, and then number in the bottom right. Okay, so when we're doing this, again, we've got to think about what needs to go where, so we multiply to get all the terms on the inside. So to get x cubed, I need an x squared and an x. Now, again, I want to think about where does that x squared need to go? If I put it up top here, that would mean I'm looking to multiply x squared by something to get 8x. And that means that's not going to work out, right? We have too many x's to get 8x. But if I put it over here on the side, I can multiply an x squared to get that negative 6x squared. So we want to match those up, which means that we have an x on the top there. And now, just like before, I can think about x times what gives me 8x. That would be 8. And then x squared times what gives me negative 6x squared. That would be negative 6. And then your check is always do these two values, multiply to get that number in our original equation. So it's negative 6 times 8, negative 48. Yes, it sure is. And so this factors to be x squared plus 8 times x minus 6. And that's it. So it goes so quick because we don't need to find any numbers. All right, let's do one more, and then that's going to actually conclude this video. I lied. We're going to do 2 more, and that will conclude this video. So number 2, again, let's place all 4 terms, 1 in each box, with x cubed in the top left, x squared in the top right, 7x in the bottom left, and negative 49 in the bottom right. I need to put the x squared on the same side as the x squared term, which is negative 7x squared, which makes the other length here just x. And then x times a positive 7 is 7x. And x squared times negative 7 is negative 7x squared. Now our check is negative 7 times 7, negative 49. Yes, it is. So this factors to be x squared plus 7 and x minus 7. It's really not too bad. All right, let's go ahead and do one last one. This time we're going to have more than 1x cubed, just making our puzzle piece or finding the outsides just slightly more difficult. Our setup's still the same. We're going to put our x cubes in the top left, x squareds in the top right, x in the bottom left, and 12 in the bottom right. Now in this case, I already broke my number one rule that I stress time and time again in looking for a GCF. If I would have looked closely, I could have taken out a 2 from all these terms. Now it's not necessary, but it would have, again, just allowed me to focus on some smaller values, which tends to make these a little bit easier. But it's not something that we have to do. I would have liked to have caught that GCF, but if I didn't, it is okay. And so since we didn't catch that, it just makes this a little more challenging. And so what I'm going to do is, again, think about where do I, when I'm splitting up my x cubed, where does the x squared need to go on the same side as the 2x squared, which makes this x. But now, just like the last time we factored, we need to think about how can we multiply to get 6? And that's with either 1 and 6 or 3 and 2. Now, we want to think about, if I do 1 and 6, will that work and get me one of these terms? So I put a 6 up top here. Can I multiply 6 to get 36x? The answer is yes, right? 6x times 6 would give me 36x. So I like that. I'm also wondering, if I do 3 and 2, could that work? So if I put a 3 here, does 3x times anything get me to 36x? The answer to that is also yes. It's because 3 times 12 is 36, which would make this term 2. And can I multiply 2x squared by something to get 2x squared? Yes, I can. So what's nice is we have more than one option. I can take 1 and 6 or 3 and 2. I'm going to go ahead and take 1 and 6 because that was the first thing I tried and the first thing that worked. So I have a 6x and a 1x squared. And 6x times 6 gets me to 36x. And then 1x squared times a positive 2 gets me to 2x squared. And then once again, our check is, does 2 times 6 give me to 12? Yes, it sure does. And so this factors to 1x squared plus 6 and 6x plus 2. Now, one thing that we could have done, and this again is not necessary, but I can look for GCFs in individual terms. So if I look at 6x and 2, I could take out a 2 from both 6 and 2, which is that GCF that we identified right in the beginning. So if we don't identify it right away, it can be found in the individual factors, but it really doesn't matter. We don't need that for any particular reason, just pointing it out that it is still in there somewhere. All right, that is everything I have for this video. Make sure you complete your video check-in and have a great rest.